Ethers are organic compounds containing oxygen atom as a functional group. That is, one oxygen atom is bonded to two alkyl or aryl groups. Depending upon the nature of groups bonded to oxygen atom, they are classified into two types. If both groups bonded to oxygen atom are identical, they are called simple ethers or symmetrical ethers. If the two groups bonded to oxygen atom are different, they are called unsymmetrical ethers or mixed ethers. For example, CH3OCH3 is a symmetrical ether. CH3 oxygen CH2 CH3 is an unsymmetrical ether. In common system, symmetrical ethers are named as dialkyl ether and unsymmetrical ethers are named as alkyl ether. In common system, alphabetical order need not be followed. This compound can be named as methyl-ethyl ether or ethyl-methyl ether. In IUPAC, both symmetrical and unsymmetrical ethers are named as alkoxy-alkane. In the case of unsymmetrical ethers, alkoxy is derived from lower alkyl group. This compound should be named as methoxyethane. It should not be named as ethoxymethane. It is wrong. This is taken as a parent chain. So, methoxyethane. Alkoxy or ether functional group is always treated as a branch and prefixed to the root word during the nomenclature. A few examples: ethers, common name and their IUPAC name. First one, CH3OCH3. It is a dimethyl ether. IUPAC name methoxymethane. Second, CH3OCH2CH3. Methyl-ethyl ether or ethyl-methyl ether. IUPAC name methoxyethane. CH3CH2 oxygen CH2CH3. It is a diethyl ether, commonly called ether. It is used as a solvent in a large number of organic reactions. IUPAC name is ethoxyethane. Fourth one group is secondary butyl and other group is methyl. So common name secondary butyl methyl ether. Its IUPAC name is 2-methoxybutane. Methoxy group is treated as a branch like halogen atom or methyl group, etc. Next one, tertiary butyl methyl ether. Its IUPAC name is 2-methoxy-2-methyl-propane. Methoxy comes first in alphabetical order. It is anisole, that is methyl phenyl ether or anisole. The common name anisole is accepted in IUPAC. That is, in IUPAC also this compound is named as anisole. This compound is ethyl phenyl ether. Its common name is phenetol. In IUPAC it is called ethoxybenzene. Next compound diphenyl ether. IUPAC name is phenoxybenzene. In this compound, left hand side benzyl group, right hand side phenyl group. So common name is phenyl benzyl ether. IUPAC, both phenoxy and phenyl are treated as branches. So IUPAC name is phenoxy phenyl methane. It is a single word. Last one more example. This compound is named as, there are 7 carbon atoms, third position, 1 methoxy group. So IUPAC name is 3-methoxyheptane. That is methoxy group is treated as a branch, just like a halogen atom or a alkyl group. If it is a chlorine, IUPAC name will be 3-chloroheptane. Similarly, 3-methoxyheptane. Isomerism. Ethers exhibit 4 types of structural isomerism. Ethers having 5 or more carbon atoms can show chain isomerism. In chain isomerism, isomers differ with respect to the nature of carbon chain. As an example, 1-methoxybutane and 1-methoxy 2-methyl propane are chain isomers. They have molecular formula C5H12O. First compound is 1-methoxybutane. Parent chain have 4 carbon atoms. Second compound 1-methoxy 2-methyl propane. Parent chain contains only 3 carbon atoms. Its common name is normal butyl methyl ether. Second one is isobutyl methyl ether. Second position isomerism. Ethers having 4 or more carbon atoms can show position isomerism. Example, 1-methoxypropane and 2-methoxypropane are position isomers. Normal propyl methyl ether and isopropyl methyl ether are examples for position isomers. They have general formula C4H10O. Third one, functional isomerism. In functional isomerism, isomers differ with respect to the nature of a functional group. Ethers having 2 or more carbon atoms can show functional isomerism with saturated monohydric alcohols. For example, dimethyl ether and ethyl alcohol have same molecular formula C2H6O. One compound is an ether and other compound is an alcohol. So they are examples for functional isomers. Fourth one, metamerism. In metamerism, isomers differ with respect to the nature of groups bonded to a divalent functional group such as oxygen atom. For example, 1-methoxypropane and ethoxyethane. These two compounds have a same molecular formula C4H10O. They differ with respect to the nature of alkyl groups bonded to oxygen atom. First compound, left hand side propyl group or normal propyl group, and on right hand side methyl. In the second compound, both sides have ethyl groups. So isomers differ with respect to nature of alkyl groups bonded to oxygen atom. This type of structural isomerism is called metamerism. It is shown by compounds having divalent functional group such as ketones, ethers, secondary amines, thioethers, etc. Only compounds having a divalent or a trivalent functional group can show this type of isomerism. Trivalent functional group, an example is a nitrogen atom found in tertiary amines. Metamerism is shown by organic compounds having a divalent or a trivalent functional group. Examples for divalent functional groups are oxygen atom in ethers, C double bond O in ketones, NH group in secondary amines, sulfur atom in thioethers. An example for trivalent functional group is nitrogen atom found in tertiary amines. In addition to this structural isomerism, ethers having a asymmetric carbon atom can also show optical isomerism. The minimum number of carbon atoms required is 5. Example, 2-methoxybutane or secondary butyl methyl ether. The second carbon atom is asymmetric. It is bonded to 4 different atoms or a group of atoms. Hence, this compound can show optical isomerism. One isomer is having R configuration and other having S configuration. Or one is destrorotatory and other is levorotatory.